Section 10.2 is exploring chord properties. To start with, we need to look at a definition. A perpendicular bisector of a chord. So a perpendicular line, it starts at the center of the circle and it bisects a chord. So if you've got an example here. We've got a line that goes from the center of the circle out to the outside. So it's just a radius. But it splits this chord into two equal pieces. That's what these ticks mean, that they're equal length. When it does that, it creates a 90-degree angle with that chord. So that's why it's called a perpendicular and then bisector of the chord. So bisect means to divide it into two equal pieces. Example 1, working example 1, bisect a chord with a radius. So radius CD bisects chord AB. We've got radius CD bisects the chord AB. AB itself is 8 centimeters. And the radius is 5 centimeters. So the question is, what is the length of the line segment CE? And then we need to justify our answer. So here's how we go about doing that. CD is a radius that bisects the chord AB, which means CD then is perpendicular to AB, which means we are creating a little right angle triangle there. A perpendicular makes a 90-degree angle. So AEC is 90 degrees. CD divides AB in half, so A to E is the same as E to B. If AB is 8 centimeters, then each of AE and EB are half that, so they're 4 centimeters. And we know that our radius was 5. Label the length of AC on the diagram. So if this is our radius, and it's 5, this also is a radius, because it still goes to the center of the circle, so it is also 5. And we know that this is 4. And in this case, we're dealing with centimeters. Since AEC is 90 degrees and you know two sides of the triangle, you can use Pythagorean Theorem, or the Pythagorean relationship, to find this unknown length of CE. When you do that, AC squared is equal to AE squared plus CE squared. That's your Pythagorean relationship. So CE is the unknown. AE we said was 4, and AC we said was 5. So 4 squared is 16. 5 squared is 25. So we can fill those in. Now we're going to subtract 16 from both sides to try and get the CE squared by itself. So subtract 16, subtract 16. Those two 16s cancel each other out, leaving you with CE squared on the left. 25 minus 16 is 9. So we've got CE squared equals 9. Take the square root of both sides. You get CE is the square root of 9, which is equal to 3. So the length of CE is 3 centimeters. So you can draw that, 3 centimeters. Now if I'm not mistaken, the numbers 3, 4, and 5 are actually called a Pythagorean triplet. If you've got legs of length 3 and 4, your hypotenuse is going to be 5. So that's that one there. Next up is a show you know, give it a try.